Imagine falling into darkness so complete it swallows even light. This is the ultimate cosmic freefall, a journey into the heart of a black hole, where the laws of physics are pushed to their absolute limits. At the edge of a black hole, known as the event horizon, time slows to a crawl, then stops entirely. Here, the pull of gravity is so intense that not even light can escape its grasp. To an outside observer, you'd appear frozen at the brink, never quite crossing over. Your final moments would seem to stretch on forever, suspended in time. But for you, the plunge is instant and final. The moment you cross the event horizon, there's no turning back. As you fall, gravity stretches your body into a thin strand, spaghettification. Every atom is pulled apart, drawn towards the center by unimaginable forces. This isn't science fiction. It's the reality predicted by Einstein's theories of general relativity. Black holes are among the strangest and most mysterious objects in the universe. Black holes warp space and time to their limits, creating a one-way trip into the unknown. Once inside, all paths lead deeper, with no escape. The rules of our universe break down here. Space and time twist beyond recognition. Reality itself becomes distorted, and the familiar laws of nature no longer apply. You become a traveler at the edge of reality, witnessing the end of time as you know it. It's a place where the past, present, and future blur together. The journey is both terrifying and awe-inspiring, a cosmic paradox where an instant for you lasts forever for the universe. It's a place of ultimate mystery and wonder. Let's step to the edge of this abyss and imagine what it's like to fall in. What secrets might be waiting on the other side? This is the story of the universe at its most extreme, a journey into the unknown, where the very fabric of reality is rewritten. A black hole begins with the dramatic death of a massive star, one much larger than our own sun. For millions of years, the star's nuclear fusion pushes outward, creating a delicate balance against gravity's inward pull. This process fuels the star's brilliance and keeps it stable for most of its life. But when the fuel finally runs out, gravity wins in an instant. The core collapses in a fraction of a second, faster than you can blink. The outer layers explode outward in a spectacular supernova, lighting up the galaxy, but the core keeps shrinking, growing denser and denser. If the core is heavy enough, it collapses into a single point of infinite density, a singularity, where all the star's mass is squeezed into an unimaginably tiny space. Here, the familiar laws of physics break down. Space and time themselves lose their usual meaning, twisting into something strange and unknown. The gravity is so intense, it warps space-time into a deep well. Nothing can escape, not even light itself, making the black hole invisible. That's why it's called a black hole, a region where light is trapped, hidden from our eyes, and only its effects can be seen. It's not an empty hole, but matter crushed into an impossibly small space, surrounded by swirling clouds of gas and dust. Once you get too close, past the event horizon, escape is impossible. No signal, object, or even light can return. Black holes are the ultimate ghosts of dead stars, where gravity reigns supreme and the past is erased forever. They are the universe's most mysterious objects, challenging our understanding of reality and inspiring endless curiosity. Every black hole has an invisible boundary, the event horizon. It's a mysterious border, a cosmic line drawn in the fabric of space and time. It's the point of no return, like the edge of a waterfall you can't paddle away from. Once you cross it, there's no turning back. Gravity's grip is absolute. Cross it, and you'd need to travel faster than light to escape. Impossible, even for the fastest thing in the universe. Not even light can break free. Now, imagine falling in while your friend watches from a safe distance, unable to help, witnessing your journey from afar. To them, your movements slow down as you approach the event horizon. Time seems to stretch and drag, almost to a halt. The light from you stretches, reddens, and fades. You appear frozen at the edge forever, a ghostly image suspended in time. Time itself is stretched to a standstill for an outside observer. The closer you get, the slower you seem to move, until you're barely moving at all. But for you, nothing feels different as you cross the event horizon. There's no sudden jolt, no warning, just the silent pull of gravity. Time ticks normally. You float right through, unaware of the boundary. The universe behind you seems to race ahead. Looking back, you'd see the universe speed up, the future flashing by in moments. Centuries could pass in the blink of an eye. Your journey is a one-way trip into darkness. There's no escape, only the unknown ahead. The event horizon marks the true beginning of your fall, the start of a journey no one has ever returned from. For the outside world, you're frozen in time, a permanent shadow at the edge of forever. For you, the plunge continues, deeper into the unknown with mysteries waiting in the darkness. The heart of darkness awaits, holding secrets that may never be revealed. Past the event horizon, the real horror begins. Spaghettification. The black hole's gravity pulls harder on your feet than your head, stretching you out. This tidal force elongates your body, turning you into a human noodle. At first, it's subtle, but the stretching intensifies as you fall. Eventually, the force overwhelms your body's bonds. Bones snap, muscles tear, atoms scatter. Your spaceship suffers the same fate, shredded into ribbons of matter. Spaghettification is gravity's ultimate deconstruction, reducing everything to fundamental particles. No object, no matter how strong, can resist. The process is a grim demonstration of gravity's absolute power. In the heart of a black hole, complexity is destroyed, only streams of atoms remain. This is the universe's most extreme transformation. The singularity pulls you in, stretching you to the limit. There is no escape from the cosmic noodle maker. The bizarre effects near a black hole come from Einstein's theory of general relativity. Gravity isn't just a force, it's the warping of space-time itself. Picture space-time as a stretchy sheet. A massive object creates a deep curve. Planets and stars follow these curves, not straight lines. A black hole is an infinite pit in this fabric, warping space and time to the extreme. This warping slows time, an effect called time dilation. The stronger the gravity, the slower time flows. We see this on Earth. GPS satellites experience time differently due to weaker gravity. Near a black hole, this effect is magnified. Time nearly stops at the event horizon. To an outside observer, clocks at the edge tick slower and slower. But for you, time feels normal as you fall in. This relativity is at the heart of Einstein's genius. Black holes are the ultimate test of these ideas. Here, gravity can literally stop time. What would you see as you fall into a black hole? Crossing the event horizon, you're cut off from the universe. No signals can escape. Looking back, you'd see the universe's history play out in fast forward. Light from stars and galaxies distorts, blue shifts, and accelerates. The future of the cosmos flashes by in a shrinking patch of sky. At the last moment, all light converges into a blinding point, then darkness. Ahead, the singularity isn't a point, but everywhere at once, surrounding you. The final plunge is quick, microseconds in a small black hole. Spaghettification completes, and your atoms are crushed into the singularity. Space and time dissolve. Your existence ends in the ultimate void. It's a solitary journey into nothingness. Can you survive a fall into a black hole? The answer is no. Once you cross the event horizon, your fate is sealed. But your final moments depend on the black hole's size. Small stellar mass black holes have intense tidal forces. You're torn apart before reaching the event horizon. Death is swift and brutal. You never see the time-bending effects. Supermassive black holes like those at galactic centers are gentler at the edge. You could cross the event horizon intact, with minutes or hours before spaghettification. You'd witness the universe's future, but the end is the same. Eventually, you're stretched and crushed into the singularity. Survival is impossible. Only the manner of your demise changes. The black hole always wins. Falling into a black hole is a journey to the edge of science. Here, Einstein's relativity and quantum mechanics collide and break down. At the singularity, density and gravity become infinite. Our equations fail. We need new physics to understand what truly happens inside. For the outside world, your final moment is frozen in time. For you, time ends abruptly as you're crushed out of existence. Black holes challenge our ideas of space, time, and reality itself. They show that space can bend and time can stop. To fall in is to vanish from the universe, your story erased in a timeless void. It's a humbling reminder of the universe's deepest mysteries. Black holes are among the universe's most epic stories. They force us to confront the limits of knowledge and reality. These objects shape galaxies, inspire new science, and fill us with wonder. Our curiosity drives us to explore, to build, to imagine. Every discovery adds to this cosmic tale. Stay curious, keep exploring the universe with your mind. What secrets will we uncover next? The universe is speaking, all we have to do is listen.